Hello students. So today I am doing class for class 12 science. The topic is inverse of a matrix. So in the last online class also we were doing the same topic, that is inverse of a matrix, and in that class we did how to get inverse of the given matrix using elementary row transformations and elementary column transformation. Okay, so now in that case we did elementary row transformation and elementary column transformation for second order matrix. So today we'll do how to get the inverse of the given matrix using elementary row transformation and elementary column transformation of third order matrices. So let's do this exercise, exercise 3, page number 212, and each question carries 2 marks. So let's do question number 7. So the question is, using elementary row transformation, you have to find out the inverse of the following matrices. So this matrix is of third order. Third order means 3 rows and 3 column matrix. Okay. The matrix given here is third order matrix. In the first row, the 3 elements are given, that is 0, 1, 2. Second row 1, 2, 3. Third row 3, 1, 1. So let us assume this matrix as capital A. That is, let matrix A is equal to this third order matrix. Okay. So what is the method here? How can you use elementary row transformation to get the inverse of this given matrix? Okay. So let us write here general matrix A11, A12, then A13, right? Then comes A21, A22, A23. Then we have here A31, A32, and A33. So this A11, A12, this is A22, this 22 is the suffix. So A11 means, what is the meaning of this small A11? This is the element belonging to the first row and first column. First row and first column, A11. A22 is the element belonging to the second row and the second column. Second row and second column, this element. A32 means element belonging to the third row and second column. Third row and second column. That means in the suffix, this first number denotes the row and the second number denotes the column. Is that clear? So what is the method? Now using elementary row transformation. Using elementary row transformation, you have to find out the inverse of this matrix. Okay. So what is the method here? So actually in this case, you have to write down A is equal to IA. This is the formula, right? And you know that identity matrix into given matrix A is equal to A itself. Okay. So now let us write down A matrix. What is A matrix here? 0, 1, 2, second row 1, 2, 3, and what is the third row? 3, 1, 1, right? Which is equal to, what is I here? I is the identity matrix of order 3. So you can write here 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0. This is 1 and this is your A, right? So this I is the identity matrix of order 3. So this leading diagonal, in the leading diagonal, all the elements are 1 and all other elements are 0 out here. Okay. And this A is the matrix A here. Now in this case, what we will do here is, now we have to convert this matrix A, which is on the left hand side, into identity matrix. So if you convert this matrix A into identity matrix, this identity matrix will be changed. So from here we can get the inverse of the given matrix. So how will we convert this matrix A into identity matrix? So let us write the A matrix like this. Okay. So I am telling you the method. So how can you change this matrix into identity matrix? So first of all, this is the leading diagonal. A11, A22, A33 is the diagonal elements, right? Now first of all, you have to convert this A11 into what? Number 1. त सबभन्दा पहिला हामीले के गर्नुपर्छ, यो A11 लाई चाहिँ हामीले केमा कन्भर्ट गर्नुपर्छ, 1 मा कन्भर्ट गर्नुपर्छ, ठीक छ। देन downward direction A21, you have to make it 0, you have to make it what, 0. Again downward direction, also you have to make this A31 0. Then go to the up right direction, that is A22. Now go to this element A22, you have to make this A22 1. Okay, so if you make this A22 as 1, then you have to make this downward direction and this is upward direction. That means you have to make this element A12, you have to convert this A12 into 0 and A32 into 0. You have to make these two elements, that is A12 and A32 as 0. You have to convert this A12 and A32 into 0. Okay, then again you have to go this direction. You have to convert this A33, that is third row and third element, third row and third column. You have to change this A33 element into 1. So if you change this A33 into 1, then you have to go upward direction. That means you change A23 into 0 and you change A13 into 0. Then what will you get? All the leading diagonal will be 1, right? And this is 0 0 0 0 0 0. This will be converted into identity matrix. So in this way we can change this matrix A into identity matrix, that is 1 0 0 0 1 0 and 0 0 1. So this is the method, right? So first of all the method is A11. यो A11 लाई हामीले केमा चेन्ज गर्नुपर्छ, 1 मा चेन्ज गर्नु पर्यो. After that go to downward direction, तो A21 लाई पनि 0 बनाउने, A31 लाई पनि 0 बनाउने. Then go to this element A22, that is second row and second column. The element is A22, you change it into 1, right? Then change these two elements which is above A22 and below A22, right? Now you have to change this A12 into 0 and A32 into 0. This will be 0 1 0. Then after that you go to the element A33. Now change this element A33 into 1. Then go to the upward direction. Then change these elements A23 and A13 into 0. So that we can have the identity matrix here. That is 1 0 0 0 1 0 and 0 0 1. All the leading diagonal will be 1 in that case. So in this way you can change this A into identity matrix 1 0 0 0 1 0 0 0 1. This will be I, and this I will be changed automatically using elementary row transformation. That too, elementary row transformation means you have to use properties of determinant in terms of rows to make this A into identity matrix. So this identity matrix will be changed automatically. Then A is taken to the left hand side. When A is taken to the left hand side, it becomes A inverse. Then you can easily get the matrix A inverse. Is that clear? So now let us do the method. So now let us use elementary row transformation to find the inverse of the matrix A. So first of all, we write here capital A is equal to IA. A is the given matrix. Okay, we have assumed this given matrix as A. So use the formula A is equal to IA. You copy this matrix A. I means identity matrix 1 0 0 0 1 0 0 0 1 and A. Okay. So now what is the method here? First of all, this is A11 element. You have to make this 0 1. How can you make this 0 1? Using elementary row transformation. You have to use properties in terms of row, right? Now 0 plus 1 R1 plus R2 garda के हुन्छ यो, this 0 becomes 1. That means R1 is equal to R1 plus R2. So let us use, now we are changing this 0 into 1. How can you change it? 0 plus 1 is 1. That means R1 plus R2 is 1 here. Okay, so R1 is equal to R1 plus R2, or R1 arrow mark R1 plus R2. That means row 1 is changing. This row 1 is changing out here. Okay. So, or now how does it change? R1 plus R2, 0 plus 1, 1, 1 plus 2, that is 3, 2 plus 3, that is 5, right? So other row remains same, that is row 2 and row 3 remain same, that is 1, 2, 3, this is your 1, 2, 3, right? Then 3, 1, 1, then this is 3, 1, 1, which is equal to, on the right hand side also. So in this identity matrix also you have to use this property R1 arrow mark R1 plus R2. That means here also row 1 is changing. How does it change? R1 plus R2. 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, that is 0. Other rows remain same. That is 0, 1, 0. Then this is 0, 0, 1. Now you can write here A. Is it clear now? Next, so what is the method now? You have to make these two elements below 1. So in the first column, the first element is 1 now. So now you have to change this 1 and 3 into 0. That means you have to change this A21 and A31 into 0. This should be 1, 0, 0 by using properties of determinant, right? That is R2 minus R1 will give you this one 0. And how can you make this 3, 0? R3 arrow mark R3 minus 3 R1. If you multiply row 1 by 3, this will be 3. And if it is subtracted from row 3, you will get here 0. That means R2 is changing here. R2 is equal to R2 minus R1, and you have to change row 3 also, because you should make this 3 0. How can you make it 0? Using row 1. R3 arrow mark R3 minus 3 R1. That means this first row must be multiplied by 3 and it should be subtracted from row 3 to make this 3 0. Is that clear? So let us change it now. Or what is now, only row 2 and row 3 are changing here. Okay, but not the first row. Let us write 1, 3, 5. So how does this row 2 change? R2 minus R1, that is 1 minus 1, 0, 2 minus 3, minus 1, 3 minus 5, minus 2. Is that clear? 3 minus 5 is minus 2. Next, how does row 3 change? That is R3 minus 3 R1. R3 means 3, minus 3 into 1 is 3. Row 1, that is this one. 3 minus 3 is always 0. Next, what is R3 here? 1. Here R3 is 1 and R1 is 3 here. So it is 1 minus 9. What is 1 minus 9? What is 1 minus 9? Minus 8. Is that clear? This is R3 is 1 minus 3 3s are 9. 1 minus 9 is minus 8. Okay. Next. Now this element also changes out here. So R3 is 1 minus 3 into 5. Row 1. 1 minus 3 into 5, that is 1 minus 15. That is, it is 1 minus 15 is minus 14, which is equal to, now you have to change the right hand side also. So first row remains same out here. This is 1, 1, 0, right? So how does row 2 change here? R2 minus R1. 0 minus 1, minus 1, 1 minus 1, 0, 0 minus 0, that is your 0, right? So next, R3 minus 3 R1. R3 is 0, minus 3 into 1, minus 3. So it is minus 3, right? Again, 0. R3 is 0, minus 3 into 1. R3 is 0, minus 3 into 1 is minus 3 again, right? And this element also changes. That is, this is 1 minus 3 into 0. 1 minus 3 into 0 is always 1. Then you should write here A. So I think you have understood it. Okay. So next one. Now what will you do in the next step? Now you have to make this minus 1 1. So how can you make this minus 1 1 now? You have to change this minus 1 into plus 1, so that we can have here 1. right? So you have to multiply this second row by minus sign, right? That is, again row 2 is changing out here. So row 2 is changing. How does it change? Minus R2. That means you have to change all the elements of the second row by minus R2. You have to change, or you have to multiply all these elements of the second row by minus sign. Okay, so or now how does it change? R2 is equal to minus R2. So what is the first row? First row remains same, 1 3 5. Here second row changes. How does it change? Multiply by minus sign. 0 1 2. Third row remains same, 0 minus 8 minus 14, which is equal to on the right hand side also second row changes. How does it change? First row remains same, second row is multiply by minus sign, 1 0 0, and third row remains same, minus 3 and 1, and this is your A, right? So we have changed this element, that is A to 2. That means element belonging to the second row and second column, that is 1. This is 1. Now you have to make this 3 0 and 8 0. This should be 0 1 0 form, right? So how can you make this 3 row? How can you make this 3 0 using second row? 3 minus, that is R1 minus 3 into R2. If you multiply 1 by 3 and it is subtracted from row 1, 3 minus 3 will be 0. Similarly, you have to make this minus 8 0 using R2 minus 8, that is row 3 plus 8 into row 2. Minus 8 plus 8 into 1 is, it is 0. Is that clear? So let us write down the property out here. That is R1 arrow mark, R1 minus 3R2 and R3. This is row 3, row 3, right? Row 3 arrow mark, row 3 plus 8 R2. This row 2 should be multiplied by 8 and it should be added to row 3. It should be added to row 3 so that this minus 8 is changed into 0, right? So let us use this property now. Or next, how does R1 change? R1 minus 3 R2, right? So 1, R1 is 1 minus 3 zeros are 0. That means it is 1, right? Similarly 3 out here. R1 is 3 here, minus 3 into 1 is 3. 3 minus 3 is 0. Next, this is your 5 minus 3 into 2. Here R1 is 5, R2 is 2. So it is 5 minus 6, that is your minus 1. Is that clear? So row 2 remains same, 0, 1, 2. We are not using property for the second row out here. We are using property for row 1 and row 3 only. So row 1 and row 3 will change. So how does row 3 change now? R3 plus 8 R2. R3 is 0 plus 8 into R2 is 0. That means 0. Next, R3 is minus 8 plus 8 into R2 is 1. The minus 8 plus 8 ones are 8. 8 minus 8 will be always 0. Now this is minus 14. R3 is minus 14 plus 8 2s are 16. What is 16 minus 14? That is 2. Is that clear? Next. So on the right hand side also you have to use the same property, that is row 1 is changing out here. How does this change again? R1 minus 3 R2. R1 is 1 minus 3 ones are 3. 1 minus 3, that is minus 2, right? Again 1 is out here. 1 minus 3 zeros are 0. 1 minus 0 is always 1. R1 is 1 minus 3 zeros are 0. 1 minus 0 is always 1. So this is R1 is 0 minus 3 zeros are 0. That means 0, right? Next, it is 1 0 0. That is your second row. Remains same. Now again row 3 is changing. How does it change row 3? R3 is minus 3 plus 8 into 1. Row 2 means 1. Here R3 is minus 3. Row 2 is 1. So minus 3 plus 8 ones are 8. 8 minus 3 is always 5, right? Next, now R3 is minus 3 and R2 is 0. Minus 3 plus 8 zeros are 0. That means minus 3. Next, this one R3 is 1 and R2 is 0. 1 minus 8 zeros are 0. That is 1. And here you should write A. So I think you have understood it. Is that clear now? Next, what will you do now? Next, you have to make this 2 1. We have made the element above 1 0 and the element below 1 0. Now we have to make these 2. That is, this is the leading diagonal. The elements in the leading diagonal must be 1 to get identity matrix. Okay. Now you have to change these 2 into 1. You have to make this element, that is the third element of the first column, should be changed into 1. So how can you change these 2 into 1 now? It should be multiplied by half, isn't it? So R3 arrow mark half R3. So now in this case, you have to multiply all the elements in the third row by 1 upon 2. Okay, that is half. Multiply by half. Multiply all the elements of the third row by half here to make it 1. Okay. So next, write down, or first row remains same, 1 0 minus 1. Next, 0 1 2, 0 1 2. Next, the third row will be changed. How does it change? Half into R3. Multiply all the elements of the third row by half. Half into 0 is 0. Half into 0 is 0. Next, half into 2 is always 1. So on the right hand side also, in the third row, all the elements must be multiplied by half. Okay. First row remains same, minus 2 1 0. Second row remains same, 1 0 0. And now how does it change third row? Multiply by half. Each and every element of the third row must be multiplied by half. That is, it is 5 by 2, then minus 3 by 2, minus 3 by 2, then 1 upon 2. Then you can write A there. Is that understood now? So now what will you do? Now this element is 1. That is the leading diagonal. 1 1 1. We have made this element 1. So now you have to make the elements which is above 1. It should be 0 here. यो जुन चाहिँ 1 को माथिबाट यो दुईटा नम्बर छ 2 र -1, यसलाई चाहिँ हामी के बनाउनु पर्छ? 0 बनाउनु पर्छ. ठीक छ? अब हामी के गर्छौं? यो त 1 भइगयो. त यो 1 को माथिबाट जुन चाहिँ यो दुईटा एलिमेन्ट छ -2 र 2, यसलाई चाहिँ यो दुईटा एलिमेन्टलाई चाहिँ हामी 0 बनाउनु पर्छ by using properties of determinant. So how can you make this -1 0? You have to use the third row. With respect to the third row, you have to make this -1 0. -1 plus 1 is 0, isn't it? That means R1 plus R3. How does row 1 change? R1 plus R3, and you have to make this 2 0 using row 3, not row 1, row 3, right? So R3 arrow mark R3 minus 2 R1. Now this one should be multiplied by 2, and it should be subtracted from sorry, it is R2. We are changing R2, not row 3. R2 is equal to R2 minus 2 R3, right? We are changing row 2 with respect to row 3. So how does it change? R2 arrow mark R2 minus 2 into R3. That is, you have to multiply this 1 by 2, and it should be subtracted from row 2 so that row 2 will be changed. Is that clear now? So we are making this -1 0 and 2 and 2 also 0. So, or now what is row 1 now? How does it change row 1? R1 plus R3, 1 plus 0, 1. Again, 0 plus 0 is 0. -1 plus 1 is always 0. So this is your row 1. Okay. Now how does row 2 change? R2 minus 2 R3. R2 means 0 and R3 means 0. 0 minus 2 zeros are 0. Right? Next, this one. 1. R2 is 1. R3 is 0. 1 minus 2 into 0. 0. 1 minus 0 is always 1. Is that clear? Similarly here, 2. R2 is 2 and R3 is 1. 2 minus 2 into 1. 2 minus 2 will be 0 here. So third row remains same, that is 0, 0, 1. So we have changed this A matrix into identity matrix. Okay. So is equal to, similarly you can change this matrix on the right hand side. So how does it change? R1 is equal to R1 plus R3 again. Minus 2 plus 5 by 2. How much is it? 5 by 2. That is R1 is minus 2. R1 is minus 2 plus R3 is 5 by 2. So 2 2s are 4. Minus 4. 5 minus 4 is 1. That is half. This will be your half. Next, R1 plus R3. 1 minus 3 by 2. R1 is 1 and R3 is minus 3 by R3 is minus 3 by 2. So it is 1 minus 3 by 2. What is it? 1 minus 3 by 2. That is minus half. Right? Then R1 is equal to R1 plus R3. 0 plus half. That is your half. Is that understood now? Next, how does row 2 change? R2 minus 2 R3. This is 1. This is row 2 is 1 and R3 is 5 by 2. So here it is 1 minus 2 into 5 by 2 is minus 5. Minus 5 plus 1 is minus 4. Right? 1 minus 5 is minus 4. Similarly, you can change this element in the second row. Here R2 is 0 and what is R3? R3 is minus 3 by 2. Here R2 is 0 and R3 is minus 3 by 2. So R2 is 0 here. Minus 2 into minus 3 by 2. Minus into minus plus 2 gets cancels. You will get only 3. Is that understood? Next, this element in the second row will be changed now. How does it change? R2 minus 2 R3. Here R2 is 0 and R3 is half. So 0 minus 2 into half is minus 1. Minus 1 plus 0 is minus 1. Is it clear now? So next, keep the third row as it is, right? So it is 5 by 2, then minus 3 by 2, then it is half. Then you can write here A. Is it clear? Next, now we have changed this left hand side matrix into identity matrix. So you can write here I is equal to, this matrix remains same, half minus half, and this is half minus 4, 3 minus half. So it is 5 by 2, right? So it is 5 by 2, then minus 3 by 2, half into A. Now A, take it to the left hand side. So what does it become? It becomes matrix A inverse dot I is equal to, this is half minus half, half minus 4, 3 minus 1. Is that clear? Then 5 by 2 minus 3 by 2, then this is half. So I think you have understood it. What is A inverse dot I? It is your A inverse, which is equal to, what is the answer now? So this is the answer. This is the A inverse, right? So you can take common here also. So what is common here? Half. You can take half as common. You can take half as common out here from all these elements. If you take half common, what does it become? 1 minus 1, 1. But this one becomes, from minus 4, 3 and minus 1, we are taking half common. So it will be minus 8. It will be 6. It will be minus 2. Then this becomes, half is taken common here. It will be 5 minus 3 and this is 1. So this is the final answer. So this is your A inverse. So I think you have understood it. This is quite difficult. So you have to practice it at home. If you practice it at home, it will be easier for you to get inverse of a given matrix using elementary row transformation. Okay. So I'll show you another example. So now I am showing you the next question, that is 7 number 3. You can use the same method that we have done in 7 number 2. So let us revise it again. Okay. So now in this case also you have to use elementary row transformation to find the inverse of this given matrix. Let the given matrix be A. So we can use this formula. The formula is A is equal to IA, right? So let us write A here. What is A now? It is 1, 2, 3, 2, 5, 7, minus 2, minus 4, minus 5, which is equal to, what is I here? 1, 0, 0, 0, 1, 0, and it is 0, 0, 1. Then you should write here A. Now you have to change this matrix A into identity matrix, and this identity matrix will be automatically changed, and that will give you the inverse of the matrix A. Okay. And now in this case, now this is the first element 1. अब मेथड चाहिँ के हुन्छ भने भन्दाखेरि यो अगाडिको एलिमेन्ट फर्स्ट कलमको अगाडिको एलिमेन्ट 1 यो 1 नै हुनुपर्छ 1 अलरेडी छदैछ ठीक छ त 1 अलरेडी छ भने यसलाई फेरि 1 बनाइरहनु परेन किनभने इट इज अलरेडी 1 अब यो तलतिर जानु फेरि डाउनवर्ड डाइरेक्सन अब यो 2 र -2 लाई हामी के बनाउँछौ 0 बनाउँछौ पहिला ठीक छ 2 र -2 लाई 0 बनाउँछौ युजिङ properties in terms of rows, right? Then after that यो माथि एरो मार्क माथिपट्टि जानु यो 5 यो जुन चाहिँ लिडिङ डायगोनलको सेकेन्ड एलिमेन्ट छ 5 यसलाई हामी के बनाउँछौ 1 बनाउँछौ so after making this as 1 you have to make this below above 5 there is 2 and below 5 there is 4 you should make these two elements as 0. Then after that you have to make this third element of the leading diagonal 1, and then you have to go upward direction. Then you have to go in the upward direction. Then you have to make this element 7 and 3 as 0, 0. So that we can have here all the leading diagonal will be 1 and all the elements will be 0 out there. So it is converted into identity matrix so that you can easily get inverse of the matrix A. Okay. So it is already 1. So I told you that you have to make these 2 and -2 0 by using properties in terms of rows. So how can you make these 2 0? You have to multiply 1 by 2 and subtract it from row 2. Subtract it from row 2, right? How can you make this -2 0? You first multiply this 1 by 2 and add it to row 3. Okay? So the property here is R2 arrow mark R2 minus 2R1 and R3 arrow mark R3 is -2 already there. -2 is already there. So this one should be multiplied by 2 and it should be added to row 3. So R3 plus 2R1. So let us use this property, right? So or now it is first row remains same 1 2 3, right? So R2 minus 2R1, here R2 is 2 and R1 is 1. Use that property R2 minus 2R1. 2 minus 2 into 1, that is 2 minus 2, it will be 0, right? Next 5 is there. 5 this R2 is 5 here and R1 is 2 out here. So it is 5 minus 2 2s are 4. 5 minus 4 is always 1. Is that understood? Next, this 7 also changes. R2 is 7, R1 is 3. This R1 is 3 here. So R2 is 7 minus 2 into 3, 6. 7 minus 6 is always 1. So I think you have understood it. Again, how does that row 3 change? R3 plus 2R1. The R3 means -2 here and R1 is 1. So -2 plus 2 ones are 2. -2 plus 2 is 0. Next, -4 also changes. How does it change? -4, right? This is -4, right? R3 is -4, R1 is 2. So -4 plus 2 2s are 4. That is, it is 0. -4 plus 2 2s are 4, 0, right? Next, here R3 is -5 and R1 is 3. So -5 plus 3 2s are 6. 6 minus 5 is always 1. Is that understood? So how does it change? R3 is equal to R3. R3 means minus 5 plus 2 into what is R1 here? 3. So this is 3 to the 6 minus 5 is always 1, right? So, so this will be 1. I think I've understood it, right? So next, also you can use the same similar properties on the right hand side, right? So now how does it change? R2 and R3 are changing, but not row 1. Row 1 remains same, 1 0 0, right? So how does row 2 change? R2 minus 2 R1. R2 is 0 here. R2 is 0 minus 2 into what is R1? 1. So which is equal to minus 2. That means it becomes minus 2, right? Is that understood? So next one is R2. R2 means 1, right? This R2 means 1 minus 2 zeros are 0. So 1 minus 0 is, this is 1. Again, R2 minus 2 R1. 0 minus 2 zeros are 0. That means it is 0. Is that clear? So now row 3 is changing. All the elements in the third row will be changed. How does it change? R3 plus 2 R1. 0. R3 is 0 plus 2 into R1 is 1. Isn't it? R3 is 0 plus 2 ones are 2. That means it is 2. Similarly, second element of the third row will be changed. How does it change? R3 is 0 plus 2 into R1 is 0. 0 plus 0 is always 0. Next, this is 1. R3 is 1 and 2 zeros are 0. R3 is 1 and 2 zeros are 0. 1 plus 0 is always 1. And this is your A. Is that clear? So now we have changed this 1 as this is 0 0. We have changed these two elements 0, and also we are getting 1 out here. Actually you have to change this number into 1, but already we got number 1, and below 1 there is 0 again. So it's correct. Okay, only you have to make these two 0 now, because this 0 is already 0. So make these two as 0. Okay, it should be 0 1 0. So how can I make these two 0 using second property? So this one should be multiplied by 2 and it should be subtracted from row 1, and this row 1 will be changed. Okay, so you have to use property in only row 1. So R1 arrow mark R1 minus 2R2, right? So R1 minus 2R2. Okay, so now you have to use property only in the first row. Only in the first row you have to use the property. Okay, so how can you use the property here? R1 is equal to, or arrow mark R1 minus 2R2, so that these two will be 0 out here. Okay, so R1 is changing. How does it change? R1 minus 2R2, that is R1 is 1, R2 is 0. 1 minus 2 zeros are 0. 1 minus 0 is always 1. Okay, this 2 is also changing. How does it change? R2 is 2 minus 2 ones are 2. 2 minus 2 is always 0. Again this is changing. 3 minus 2 into 1 2. 3 minus 2 is always 1, right? So other rows remain same. 0 1 1 0 0 1, right? So I think you have understood it. So which is equal to, on the right answer also you can change row 1, that is R1 minus 2R2, right? So it is 1. R1 is 1, right? R1 is 1 minus 2 into minus 2. Minus 2 into minus 2 is plus 4. Plus 4 plus 1, it is 5, right? Then 0. 0 minus 2 ones are 2. R1 is 0, R2 is 1, right? 0 minus 2 ones are 2. So how much is it? Minus 2, right? Again row 1 is changing here. R1 is 0, R2 is 0. That means 0 minus 2 zeros are 0. That means 0. So row 1 is changed. Next, other row remains same, minus 2 1 0, and it is 2 0 1. And this is your A. Is that clear to all of you? So next, what will you do now? Next, what will you do? So now this is already made 1, isn't it? This is already made 1. This is the leading diagonal, and in the leading diagonal the third element is 1. Now you have to make the elements above 1 0. Both these two elements must be made 0, so that we can have here in the leading diagonal all the elements will be 1 and all the elements will be 0. That means you have to make this 1 and 1 0. How can you make it 0? Using third row, R1 minus R3, 1 minus 1 is 0. This one should be made 0. R2 minus R3, 1 minus 1 will be 0. Is that clear? So let us write here now R1 arrow mark R1 minus R3 and R2 arrow mark R2 minus R3, right? So these two properties must be used in order to convert this left hand side matrix into identity matrix. Okay, so now R1, row 1 is changing. How does it change? R1 minus R3, 1 minus 0, 1, 0 minus 0, 0, 1 minus 1, 0. Again row 2 is changing. How does it change? 0 minus 0, 0, 1 minus 0, 1, 1 minus 1, 0. Row 3 remains same, 0, 0, 1, right? Which is equal to, now on the right hand side also same properties must be used. R1 is equal to R1 minus R3, 5 minus 2, R1 minus R3, isn't it? 5 minus 2 is 3, minus 2 minus 0 is minus 2, and R1 minus R3, 0 minus 1 is, this is your minus 1, right? That is 0 minus 1 is minus 1, right? Again row 2 is changing. How does it change? Row 2 minus row 3, minus 2 minus 2, minus 4, R2 minus R3, 1 minus 0, 1, 0 minus 1, this is your minus 1. Is that clear? And row 3 remains same, that is 2, 0, 1. And there is A out here, okay? You have understood? You should write A here. So now this is changed into I. So this is your I, and this is 3 minus 2 minus 1 minus 4 1 minus 1. This is 2 0 1, and this is your A, right? Now A, take it to the left hand side. So what does it become? A inverse dot I is equal to, now this is 3 minus 2 minus 1 remains same, this matrix remains same, then this is 2 0 1, right? So next one is, now what is the answer here? A inverse dot I is always A inverse, which is equal to, so you can copy that matrix. This is your A inverse, right? So 3 minus 2 minus 1, next minus 4 1 minus 1, is that correct? Then 2 0 1, then this is 2 0 1. So this is the answer. So I think you have understood it, okay? So you can revise these two problems at home, practice it at home, okay? So if you don't understand anything, you can write down the comment, or you can call me also, okay? So this much is for today. So in the next class we will do using elementary column transformation. You have to find out the inverse of the given matrix. That will be done in the next online class, okay?